Okay, so what we have done, that we have already checked that our variable y has unit root, that we have already found in the previous video. And what I have done here, I have converted this y variable into first difference, that is dy, right? And this is my variable dy, the first difference. And now I want to check whether this dy variable has got unit root or not. That we want to check as before. Okay, so what I do, I go to statistics as before. I go to statistics and go to time series and go to test, augmented decay-fuller into test, right? Click here, and here I choose the variable. Last time it was y, now it is dy. So I choose dy, the first difference of y. Okay, and we have three decay-fuller model. The first model has intercept, second model has intercept and trend, and the third model has no intercept and no trend. Okay, first I check the first one. The first model has intercept. So here I keep all blank, right? Only choose this one, and here I choose lag 4, right? And everything is set, right? Then I proceed with the result. I press OK. So that is the outcome of the results. You can see from here, lag 4, right? I have taken lag 4, and it is the test statistics, and it is the 5% critical value. And here what is happening, the absolute value of test statistics, meaning that we ignore minus sign, meaning that 4.515 is more than 5% critical value, which is 3. So and what is the guideline? The guideline is when the absolute test statistics is more than critical value, we can reject null hypothesis and can accept alternative hypothesis. And what is our null? Sorry, what is our null hypothesis? The null hypothesis is dy has unit root. And what is alternative? The dy, the variable, right, does not have unit root, right? So that is alternative. Right. Okay. So so here we can reject the null hypothesis and accept the alternative, meaning that does not have unit root. Does not have unit root, right? So, but make sure as before, and this one is our decupular model, right? And the model has only intercept, and it is here, and this model has also 4 lag, right? And all are here, 4 lag are here, but make sure the first one L1, the coefficient of L1 must be negative, and it is negative, so we can accept the model. Okay, now I check our second model. What is the second model? Second model has trend and intercept. So I check it now. Go to statistics, time series, test, augmented decupular unit root test. Okay, so the second model has trend, so I choose this one, right? And also intercept. Okay, and for second model I choose lag 5. I choose lag 5. Then I proceed for the second model. Okay, everything is set. I click OK. So here you can see the lag is 5, right? And here the absolute value of test statistics is more than critical value, right? So we can reject the null hypothesis and can accept the alternative, meaning that our variable does not have unit root, right? But make sure I click on the more. So here is the, you can see the and this one is the our decupular model having trend and intercept, right? Having trend and intercept, and it has 5 lag, right? You can see. But make sure the coefficient of this one L1, the coefficient, the value must be negative, right? And it is negative, so we can accept the decision of this model. And now finally we have the last model. So as before, I go to statistics, time series, test, augmented decupular unit root test. Okay, what is our last model? The model number 3. Model number 3 has no intercept, no trend, meaning that I click on the suppress constant term, right? And here I choose lag 4. Here I choose lag 4, and then everything is set. Then I click OK. The result has come up, right? I've chosen lag 4, right? It is here. And the test statistics, absolute value of test statistics is more than critical value, so we can reject the null hypothesis and can accept alternative hypothesis, meaning that our variable does not have unit root. And but make sure our Dickey-Fuller model, you see here is no intercept and no trend, but and it has 4 lag, right? It has 4 lag, but make sure L1, the coefficient of L1 must be negative, and it is negative. So we can accept the model. Okay. So what is our decision? That the first difference of y variable has the first difference of y variable does not have unit root, meaning that the first difference of y has the first difference of y variable is stationary. So normally when we convert a variable into first difference, the variable becomes stationary, and here the variable has become stationary after first difference. Thank you very much for being with me.